Before the split-second strikes and impossible escapes begin, consider this. Our world runs at human speed, but nature runs on milliseconds. Hidden in reefs, forests and fields, specialists train for survival. Their bodies store energy like springs, releasing it in blinding bursts. What looks like magic to us is simply their normal time. When we think of fast reflexes, most of us picture trained athletes. Baseball players reacting to a 100-mile-per-hour pitch, tennis players returning a blistering serve, or sprinters exploding off the starting line in a fraction of a second. These are feats of peak human performance, the result of thousands of hours of training sharpening the connection between mind and muscle. Even in everyday life, human reflexes are impressive within our own biological limits. We blink to protect our eyes, snatch a falling glass before it shatters, and pull our hand from a hot surface without a conscious thought. These actions feel instantaneous to us. But in the animal kingdom, the speed at which some creatures react is on an entirely different scale, almost alien. It's a world where actions are measured not in tenths of a second, but in thousandths. Many of these movements happen so quickly that they are nearly impossible to see with the naked eye. To our perception, a predator strikes and its prey simply vanishes. The event is a complete blur. To truly observe and understand them, scientists have to rely on high-speed cameras capable of capturing thousands or even hundreds of thousands of frames per second. Only then can these moments be slowed down enough for the human eye to process. Among the top champions of raw reaction speed is the mantis shrimp. At a glance, the mantis shrimp looks almost cartoonish. A small, colourful marine crustacean with bright psychedelic patterns and enormous, bulging eyes on stalks that move independently. But this seemingly harmless creature is one of the most formidable predators in the ocean, a tiny terror of the reef. The mantis shrimp possesses a pair of specialized limbs called raptorial appendages. In species known as smashers, these function like biological spring-loaded hammers, storing immense elastic energy. When the mantis shrimp strikes, it releases this stored energy with explosive force, sending its limb forward at speeds of up to 50 miles per hour, accelerating faster than a .22 caliber bullet. To put that into perspective, that's about 50 times faster than the blink of an eye. In fact, the strike happens in just 3 milliseconds. What's even more remarkable is the effect this punch has underwater. Water is dense and generally slows down movement, but the mantis shrimp strikes so fast that it causes cavitation, a phenomenon where the water literally boils momentarily due to the extreme drop in pressure behind the limb. This creates a second impact. As the tiny vapor bubble collapses, it generates intense heat, a flash of light and a powerful shockwave. So even if the shrimp somehow misses its target, the shockwave alone can stun, injure or kill prey. It's a 1-2 punch delivered with a single blow. This is why mantis shrimp have been known to crack the glass walls of aquariums. Keepers have learned to house them in thick acrylic tanks, as standard glass simply can't withstand the repeated high-velocity impacts. Not because they are large or strong in the conventional sense, but because they deliver force faster than almost any other living creature. Another animal with stunning reflexes is the dragonfly. Seen fluttering around ponds and fields, dragonflies can seem peaceful and delicate, but make no mistake, they are some of the most skilled and efficient aerial predators in the world. Their hunting success rate is above 90%. For comparison, lions, apex predators on land, have hunting success rates closer to 25%. The dragonfly is, statistically, a far more lethal hunter. The key to the dragonfly's effectiveness lies in its nervous system and wing structure. Dragonflies can move each of their 4 wings independently, allowing them to hover like helicopters, change direction instantly, and even fly backwards. This gives them unparalleled agility in the air. Their reflexes allow them to track and intercept flying prey mid-air, something very few animals can do with consistency. Dragonflies don't simply chase their prey. They calculate where the prey will be and intercept it. They create a mental model of the prey's speed and trajectory, then fly to the point of collision. This requires split-second visual processing and lightning-fast communication between their eyes and the muscles controlling their wings. Their enormous compound eyes contain up to 30,000 individual facets, giving them nearly 360-degree vision and an incredible ability to detect motion. They can detect the slightest movement from meters away and respond without a moment's hesitation. When a dragonfly decides to strike, the entire event, from detection to capture, is over in less than 1/10 of a second. Then there are the trapjaw ants, small, commonly overlooked insects with a hidden superpower. These ants have some of the fastest recorded reflexes of any animal on Earth. Their jaws, which open to a full 180 degrees, are held in place by a latch mechanism, storing energy like a loaded spring. When triggered by tiny sensory hairs, they snap shut at speeds of up to 140 miles per hour, faster than any other muscle-driven movement in the animal kingdom. This incredible speed is used both for hunting small prey and for defense. This jaw snap is so fast that it generates forces over 300 times the ant's own body weight, large enough to launch the ants into the air. Scientists have observed trapjaw ants using their jaws as an escape mechanism. When threatened, they slam their jaws against the ground or a solid object and catapult themselves away from danger, a maneuver known as an escape jump. The movement happens in as little as 0.113 milliseconds, so rapidly that it appears as a blur, even when filmed in extreme slow motion. This principle of storing and explosively releasing energy is a common theme. The pistol shrimp, a relative of the mantis shrimp, snaps its claw shut so fast it also creates a stunning cavitation bubble. And the chameleon's tongue isn't just muscular, it's a ballistic projection, launched with incredible speed and precision to snatch insects from a distance. These extraordinary reflexes evolved because survival often depends on reacting faster than your enemy or your prey. It's a biological arms race played out over millions of years. Imagine the difference between catching food and starving, or dodging a predator's attack and becoming the meal. In nature, the creatures who react quickest frequently have the upper hand. But lightning-fast reflexes are not limited to predators. For every hyper-fast hunter, there is often prey that has evolved an equally rapid response system to avoid becoming lunch. Take the humble and often annoying housefly. Its ability to evade our swats is legendary, and its reflexes are something to respect. Flies process visual information about 4 times faster than humans. Their world is lived at a different temporal resolution. This means that when you swat at a fly, to them, your hand looks like it is moving in slow motion. They perceive the threat with plenty of time to calculate an escape trajectory and act on it. Their nervous system is optimized for rapid escape, allowing them to adjust their posture and launch into flight almost instantly, long before our hand arrives. Another amazing example is the hummingbird. While they are known for hovering and drinking nectar, hummingbirds also have incredibly fast neuromuscular control, essential for their energetic lifestyle. They can change direction mid-air in the blink of an eye and can beat their wings up to 80 times per second, tracing a complex figure-8 pattern to generate lift. This rapid muscle action is powered by the fastest metabolism among vertebrates and a heart that can beat over 1,200 times per minute during flight. The hummingbird's reflexes are finely tuned to avoid predators like hawks, but they are also used constantly to outmaneuver rival hummingbirds during intense territorial disputes over precious nectar sources. What all of these animals share is a nervous system honed by millions of years of evolution for one purpose: speed. Reflexes rely on the ability to sense a stimulus and react to it almost instantly. In many of the fastest creatures, the brain is not heavily involved in the immediate response. Instead, the reaction is processed through simplified neural pathways or reflex arcs that bypass slower analytical thinking. Some animals, like the squid, evolved giant nerve fibers that transmit signals at incredible speeds, allowing the entire body to react as one to escape a threat. These direct circuits allow reflexes to happen in fractions of a second, turning the animal into a pre-programmed reaction machine. Humans, by comparison, are much slower in pure reflex timing. Our fastest reactions to a visual cue are around 200 milliseconds, an eternity in the world of a trapjaw ant. Our nervous system is great for complex thought, planning, reasoning, and creativity. But this comes with a trade-off. Our brain adds processing delays. Animals that rely on speed have sacrificed some higher-level thinking for this rapid response capability. In their world, hesitation is fatal. There is no time for deliberation. In the natural world, where milliseconds determine who eats and who is eaten, speed is a form of power. It is the ultimate currency of survival. And the animals that master it operate in a reality that seems almost too fast for us to comprehend, a constant, high-speed ballet of life and death happening all around us, just beyond the limits of our perception. Another master of split-second precision is the archer fish. From beneath the surface, it spits a narrow jet of water that knocks insects off leaves above. To hit a moving target, it compensates for light refraction at the water-air boundary, predicts drift, and fires before the prey shifts. All in a blink. Then there's the tentacled snake of Southeast Asia. It freezes in a strange J shape that tricks nearby fish into launching their escape reflex the wrong way. The snake strikes into the predicted path, grabbing its meal before the fish even knows it moved. Engineers study these reflex champions for inspiration. High-speed robotics, collision avoidance drones, and predictive vision systems borrow nature's playbook. Simplify the neural path, pre-compute likely motion, and act faster than the threat arrives. In the end, reflex is more than speed, it's strategy. Nature rewards those who predict, preload, and act without hesitation. From reef to sky to forest floor, that lesson echoes. Slow it down, and you witness the hidden choreography of survival. Speed writes the script. Life follows on cue.